Okay, hey everyone, today we'll be calculating the pH of strong acids and bases. Okay, so here are the formulas to calculate pH, and the pH is just equal to the negative log of the H plus ion concentration. And yeah, if you don't know how to do logs, I would suggest that just Google it really quick. It's really not that hard. And sometimes we have to find the pOH, like, if we have sodium hydroxide, we're not going to know the H plus ion concentration right away. So we need to use the hydroxide concentration instead. So that's why we, have an equation for pOH as well. But it's all good because pH and pOH add up to 14. So yeah, so now let's go over what exactly is a strong acid and what exactly is a strong base. Okay, so a strong acid, strong acid and bases, they completely dissociate in water. Okay? Yeah, so they just completely dissociate in water. So if you have a 0.1 molar solution of hydrochloric acid, we know that we're going to have a 0.1 molar concentration of H plus ions. Likewise, if you have a 0.3 molar solution of sodium hydroxide, we know that we're going to have a 0.3 molar concentration of hydroxide ions. So that's what it means to be a strong acid and a strong base. They just completely dissociate. And this makes calculating the pH for strong acids and bases really easy because the formulas, as you just saw, the formulas is like that pH is just equal to negative log of the H plus ion concentration. And yeah, so we don't have to worry about Ka, or the acid dissociation constant, at all, which is really nice. So yeah, let's go over some practice problems. Oh wait, before we go over the practice problems, let's go over what are the strong acids and what are the strong bases. I'm sorry, I didn't think that through. So here is a list of the strong acids and the strong bases. Yeah. So here are the ones you need to know. Yeah, and you also have to memorize the names too, because sometimes they like to trick you by just giving you the name, and then you get perchloric acid mixed up. You get like sulfuric acid mixed up with hydrosulfuric acid. So you have to know the names as well. And these names are really easy actually. Like if it's just a diatomic acid, it's just hydro, then the element, and then ic. So it's hydrochloric acid, hydrobromic acid, and hydroiodic acid. And the strong bases are even easier to memorize. If the hydroxide is with a group 1 or group 2 metal, it's probably a strong base. And by group, I'm referring to the columns of the periodic table. And there are actually a lot more stronger acids and bases out there, but these are the ones you need to know for the exam. Okay, so let's do some practice problems. Let's find the pH of a 0.1 molar solution of HCl. So we know that the pH is equal to the negative log of the H plus ion concentration. But we know it's a strong acid, so we know that this number is going to be equal to the concentration, the hydrogen ion concentration, because the HCl completely dissociates. So we just plug it into the equation, and boom, we're done. So we get 1, which makes sense because, acids have low pHs. So now let's find the pH of a 0.1 molar solution of sodium hydroxide. Well, because we're dealing with the base, we have to use the hydroxide equation instead. So we have pOH is equal to the negative log of the OH minus concentration. But because it's a strong base, we know that it's gonna. We automatically know that it's gonna be 0.1. So there you go. So we're done here. The pH is 1, right? Well, no, that's the pOH is 1, but the pH is something different. And as we already went over, pOH and pH add up to 14. So to find the pH, we just need to subtract this number by 14. So 14 minus 1, and we get 13. And this number makes more sense because bases have high pHs. So yeah, guys, that's all you need to know. Calculating the pH of calculating the pHs of strong acids and bases is really easy. The hardest part is just memorizing your what are the strong acids and bases. But just go over the table earlier in the video and you'll be fine. So I hope you guys have a good night or a good day, and see you later.